Okay, and we're going to go over some of these word problems here. So this is the application. Now remember, when we're setting this up, we want to always start with defining the variables, writing the equation, solve the equation, because you could reason this out, but we want to practice using our algebra skills. So, it is at noon. At noon, a jogger leaves 1 point, running 8 miles per hour. 1 hour later, a bicyclist leaves the same point, traveling 20 miles per hour in the opposite direction. At what time would they be 36 miles apart? So I like to draw a picture. So if we start here, we have the jogger going in one direction, jogger. And they're going at a rate of 8 miles per hour. Then 1 hour later, the biker is starting at the same point, but going in the opposite direction. And this is the biker, and they're going 20 miles per hour. So we want to know together from here to here, how long until they're 36 miles apart from each other. So we don't know the time, so we would have a variable, since that is the question, at what time would they be 36 miles apart? For every hour that the jogger jogs, they've gone 8 miles. So we don't know their time, but we know we can use the variable t to represent the time that the jogger is jogging for. And then their rate is 8. So however far they are would be 8t. Because you see how I don't know the total distance of the jogger. I only know the distance of both of them combined. And we know that distance equals rate times time. What do we know, since we don't know the time of the biker, but we know the relationship, what could be an expression you could write for the time of the biker? It would be t minus 1, right? Because it's just an hour later. And then their rate is 20, so their distance is going to be distance times the time, or the rate times the time, which is 20 times t minus 1. Now, so right here we can say this is 8t is the distance that the jogger's gone. 20t minus 1 is the distance of the biker. And how would you write an equation for combining their distances to get 36? What would be the equation then? And Trey pointed out that you're kind of working backwards because you're saying, in your table, a lot of you put 36 as the distance, but notice that their distance combined. How do you combine their distances? You add them. So the distance of the jogger, which is here, plus the distance of the biker, together you're going to get 36. And what operation means combine? Add them together, right, for a total distance of 36. So your equation could be 8t plus 20 times t minus 1 equals 36. Now, I'm not sure. From there, I think you guys could probably very solidly solve it. So maybe what we should do is just move on to setting up the next one, yeah? Okay, so for the next one, it says, with the wind behind it, a plane made a flight between 2 towns in 2 hours. Returning against the wind, the plane flew 60 miles per hour slower. The return flight took 3 hours. What was the plane's speed in each direction? So this time, when they're asking us for speed, what one of these things, distance, rate, or time, is the unknown? The rate. We don't know the rate. The going trip, and here's my picture. There's my plane going. It took 2 hours going, but I don't know the rate. So technically the distance is 2 hours times however much the rate was. Well, that's the rate is the unknown, so I could use R for rate. The time was 2 hours. Coming back took 3 hours. How come it took longer to come back? It's the same distance, isn't it, in the plane? How come it took longer? the wind was working against it. How much did it slow the rate down? And so how could you write an expression for the rate returning? The rate got slowed down 60 miles per hour. Minus 60. Good. R minus 60 is the return trip, and it took a total of 3 hours. Now, if I knew what the rate was and I knew the time, I could figure out the distance. So 2R would be the distance, right? The rate times the time. So in a way, the table is set up a little backwards because you almost want the distance to be on the other end of the table. And then how would you determine the distance on the return trip? Well, 3 hours times whatever the rate was, R minus 60. Do you know anything about these two distances? They're equal to each other, exactly. So what would be the equation that you could write to solve for the rate? Yes, 3R minus 60. 2 times the rate equals 3 times the rate minus 60. Because the distance going and coming is equal. And that's why maybe drawing a picture could be helpful to help you visualize. Am I going, in this scenario, I needed to add them together, the two distances. But in this scenario, I needed to set them equal to each other because going and coming was the same. So now that we've set them up, you could go ahead and solve them, right?